is going to work on Windows on ARM on a Mac M1. So I've installed Visual Studio before, and I'll just open it here. So to open Visual Studio, you click the Start button, and you go to All Apps, which Microsoft is hidden up here because they don't like you doing it this way, because they're horrible people and they just like to waste your time hiding all the good stuff. Then you go to Visual Studio, and here you have a lot of different kinds of tools, but you can make x86 native tools, command prompt, which is 32-bit Intel code. You can make it on the Mac, on the Windows on ARM, and you can run it on Windows on ARM. So I've already made the folder here as cdcomp, and then if I do a directory, I've already compiled it here. All I did was CL to compile it, just like the instructions said, and I made this print.exe. If you look at the print source code, it's just include IOStream, void main, print. It's just going to print hello and a 2, just like we did in the project. And you can run it too, even though it's in 32-bit Intel code, it'll run on the 64-bit ARM in some kind of emulator. And there it is, printing 2 and hello. And you can open it in IDA. So here's the IDA freeware. And it's a new program I want to disassemble. And it's in C, decomp, print.exe, and I accept the default conditions of disassembly. It tells me it couldn't find a couple of signature files. I don't know what that's about, but I just ignore it and keep going. And then I get the code here, and when it's filling in the color, brother, it's done. And now I have the graphic entry, and as I said before, the original entry point is some kind, oh, here's the actual code. Here's printing hello. So in this case, it didn't hide me somewhere. I'm seeing the actual code that does it, and this is the code we talked about in the lecture. It pushes the base pointer, starts a new stack frame here, then it pushes hello, 2, and the format string, and then it calls this function, which will eventually call print. So that's what a print function call looks like in assembler. And all right. So now you can make them at global and local variables. This is going to be glob.cpp. So I'll copy this and go back to turn off IDA and don't save it. Go back to my developer command prompt and notepad glob.cpp. I've got to spell it a little better. All right, and I make a new file, and I paste in my code. It has a global variable and a local variable, which it prints. So I save that, and then I close it. And now I do a dir, and I'll see I have glob.cpp. I can compile it with CL. All right, and now if I do a directory, I have glob.exe, so I can run it. And it prints 2 and 3. And I can decompile it with IDA. And this is just following what we did in the lecture, so I don't know, I'll demonstrate any more beyond this. I'm just very pleased to observe it works in Windows on ARM. So new, glob.exe, there it goes. I decompile it with the usual settings. It complains about signature files, whatever that means. And then it gets the job done. And there it is. There's the code. It has, here's the 2 variables going. This is the global variable in another data section, 41B. Here's the local variable, EBP plus var4 in the current stack frame. It pushes them onto the stack, and then it pushes the format string on the stack, and then it calls print. So that just shows you the difference between global and local variables. And you carry on in this fashion, it should be fine. And there are various, oh, that's it, just these 2 flags to find. Oh, and then there's something unknown you have to disassemble to find. So anyway, that seems to work just fine, and that's what I wanted to show you. Gives you practice disassembling stuff and reading the assembly code a little bit. So I'm going to stop the recording.